So that was our good old decimal system. Okay, for the binary system, it's the exact same thing. Okay, difference is that we've only got two digits. Okay, 0 and 1. No energy and energy. Okay, it's how the computer sort of like understands it, right? And since we only have two digits, okay, so it's gonna be instead of 10 to the power of 0 because we had 10 digits, it's gonna be 2 to the power of 0, 2 to the power of 1, 2 to the square, and 2 to the cube, 2 to the power of 4, 2 to the power of 5, and so on. Okay, so it's the exact same thing. What is the amount? This is the question that we have to ask ourselves. What is the amount of 2's to the power of 0 that we have? Well, we can have 0 2's to the power of 0. So in other words, we can have no 2's to the power of 0 at all, or we can have 1 2 to the power of 0. Same thing. What is the amount of 2's to the power of 1 that we have? Well, we can have 0 2's to the power of 1, so no 0 to the power of 1, or we can have 1 2 to the power of 1. Same for 2 to the square, 2 to the cube, and so on. Okay? So let's try to, maybe this is going to be clearer with an example. Okay? So we have the number 10 here, which is not 10. Okay? This is the binary system. This is not 10. Okay, so let's say that I have the number 10 here. Okay, so how do I represent that in decimal? So because we're so used to counting in a decimal system that we look at this here and sort of like, yeah, this is the number 10, but then we remember, no, this is the binary system, so this must be another number. It's not number 10. So let's try to represent. So let's see what is the amount of things that is being represented in this number here. Okay, so what is the amount of 2's to the power of 1 that we have here? Well, we have 1, 2 to the power of 1. And what is the amount of 2's to the power of 0 that we have here? Well, we have no 2's to the power of 0 at all. Sorry, this is supposed to be plus. We have no 2's to the power of 0 at all. So 0 times 2 to the power of 0. Okay? Guys, any number to the power of 1 is itself, right? So we have 1 times 2 to the power of 1 is 2. 2 plus 0 times 1. 2 to the power of 0 is 1. Any number to the power of 0 is 1. So 1 times 2 is 2 plus 0, right? So in actual fact, 1 0, 1 0 in binary represents the number 2 in decimal. Okay, so 1 0 is 2. Okay, so we can say, oh, we have two apples here. Okay, I'm gonna eat two apples. Okay, so I'm gonna eat 1 0 apples. All right. Another example, the number 1 1. Okay, so 1 1. Okay, what is the amount of 2's to the power of 1 that we have? Well, we have 1. 1 2 to the power of 1 plus, what is the amount of 2's to the power of 0 that we have? Plus 1 2 to the power of 0. So 1 times, well, 2 to the power of 1 is 2, right? So 2 plus 1 times 1. Do you agree? So our result is 3. So 1 1 in binary represents the number 3 in decimal. Okay? So let's go a little deeper now. Let's see. Let's say that I want to represent the number 1011. Okay, so I'm gonna write it here. 1011. what is this number in decimal? Let's see. Well, what is the amount of 2's to the cube that I have? I have 1, 2 to the cube, 2 to the cube, plus. What is the amount of 2's to the power of 2, 2 to the square that we have? Well, we have 0, 2's squared, plus. What is the amount of 2's to the power of 1 that we have? We have 1. 1, 2 to the power of 1. And finally, what is the amount of 2's to the power of 0 that we have? We have 1, 2 to the power of 0. Okay? This is going to be equal to, guys, 1 times 2 to the cube, right? It's 2 times 2 times 2, 8, plus 0 times, what is 2 to the square? 4. Do you agree? 0 times 4, okay, plus, what is 2 to the power of 1? It's 2. 1 times 2 plus 1 times 1. 1 times 1. So the result is going to be 8 plus, well, 0 times 4 is 0. 0 plus 1 times 2 is 2 plus 1 times 1. 1. So the result is going to be 8 plus 0 is 0. 8 plus 0 is 8. 8 plus 2 is 10. 10 plus 1 is 11. So this here is 1011 in binary. So we represent this. So in decimal, this is 11. Okay, so we can represent 11 things. For example, 11 cars, 11 apples, 11 whatever, with the number 1011. So now let's do the other way around, okay? Let's say that I want to represent the number 13 in decimal. So how do I do that in binary, right? How can I do that? Well, what we're going to do is we're going to get the number 13. The number 13. We're going to divide it by 2 because it's binary, right? So 2, okay? We're going to divide it by 2, and we're going to focus on the remainder. Then we're going to go backwards, okay? You guys are going to see what I'm doing, okay? So 13 divided by 2 is 6. Okay, I was going to say 7, sorry. So 6 times 2 is 12. 12. Okay. So what is the remainder? Well, the remainder is 1. Okay. So let's continue. Now we're going to get the number 6, and we're going to divide it by 2 as well. Okay. Divided by 2. 6 divided by 2 is 3, right? So 6 minus, guys, this is a little ugly. I am sorry. Okay, but this is the remainder. 1 is the remainder. Okay. 3 times 2 is 6. Okay, so we're going to put 6 here. 6 minus 6 is 0. Okay. Now, let's divide 3. 3 divided by 2. 3 divided by 2 is 1. So 1, 2. Okay. 3 minus 2 is 1. Do you agree? All right. So now what we're going to do is we're going to get this. So now we have the number 1, right? I mean, it's not, you can't get any lower than that, right? Can't get any lower than that. Okay, once we get to 1, so now we're going to do is we're going to get this result here, so 1, and we're going to go backwards. Backwards, all right? So we're going to say 1, 1, 0, 1. Okay, so 1, it's this one here. 1, 0, 1. Okay, so this is the number 13 in binary. And just to confirm, you guys can, for example, go to, you guys are gonna, you can go to a calculator here, okay? And let's see if it is indeed number 13. So 1101. You can Google binary to decimal calculator. So 1101. Sorry, 101. Okay, let's see if it is 13. Yes, it is the number 13. 1101 is the number 13. Okay. Another example, let's say that I want to represent the number 25 in binary, okay? So it's the same thing. We're going to get 25, divide 25 by 2, okay? And we're going to work with the remainder. And once the result here becomes either 1 or 0, we're going to get the result. The result is going to be the final result. Is going to be our first digit, and then we're going to work backwards with the remainder. We're going to concatenate the final result, which is going to be either 1 or 0, with the remainder. Okay, so let's see how it is in practice. So 25 divided by 2 is 12. 12. 24. Okay, so 25 minus 24 is 1. Okay, now 12 divided by 2, 12 divided by 2. How much is 12 divided by 2? It's 6. So 6 times 2, 12 minus 12 minus 12, 0. Okay, now 6. 6 divided by 2 is 3. So 3, 6. 6 minus 6 is 0. Okay, all right, so our result isn't 1 or 0 yet, right? Sorry. So our result is still a number that is greater than 2. So we need to divide a little more. So 3 divided by 2, okay, is 1. So 2 here. 3 minus 2 is 1. Okay. Oh, our result is now 1, which is a number which is smaller than 2, right? So now we're gonna concatenate 1, 1, 0, 0, 1. Okay, we're gonna concatenate by going backwards like this. Okay, so the first digit is gonna be 1. The next one is 1. The next one is 0. The next one is 0 again. And finally, 1. Okay, let's confirm. See if this is indeed 25. 11001. Okay, let's confirm this. Binary to decimal calculator. 11001. It is indeed 25. Okay, it is indeed 25. So 11001. It is 25. In binary, 11001 In decimal, which is what we're used to, 25. Okay, so this is how um, we transform from decimal to binary. And now you guys also know, because we've just done this exercise, how to represent how to represent uh, binary numbers in decimal. Okay. Okay, so there was one other thing that I wanted to discuss with you guys, which is an interesting property of, when we're converting um, decimal numbers to binary, which is okay. Let's assume. So, for example, let's say that I want to convert 16 to binary. Okay, so I'm gonna put 16 in here. Okay, so I'm gonna divide it by two. Okay, so we can get the binary. All right, so 16 divided by 2 equals 8. Okay, so 16 goes here. 16 minus 16 is 0, right? 8 divided by 2, okay, is 4. So 8, 8 minus 8 is 0 as well. 4 divided by 2 is 2. So 2 times 2, 4. Okay, 0. Okay, so what we have here is 2. So our answer here in this calculation here, when we divide 4 by 2, is 2. Okay? But 2 is not less than 2, right? So 2 is equal to 2. So in this case, we're going to have to divide 2 by 2 again. So 2 divided by 2 is 1. Okay, so 2. All right, remainder is 0. Okay. All right. So if we go backwards, okay. So if we go back, so um this is this is gonna be on the left. Okay. It's gonna be our leftmost bit, our most significant bit. Okay. And then we go backwards. What we have is 1, 0, 0, 0, 0. So 1 and 4 zeros. Let's confirm if 16 is indeed 10000. Let's confirm it. And it is indeed. I had already done this calculation. Okay. Okay, so let's try another number here. Let's try now 64. 64 in binary. I don't know if you guys are noticing an interesting pattern here. So 64 divided by 2 in binary is 32. So 64, remainder 0. 32 divided by 2, okay, is 16. Hey, we have our 16 again. All right. Remainder 0. And the rest is just like we had discussed, right? Just before when we were trying to convert 16 to binary, right? So I'm just gonna skip it and do the calculation myself. Okay, so now we have a 64 in binary, right? So we're gonna circle our most significant bit here. Then we're gonna go backwards. All right, so 64 in binary is the same as 1, 0, 0, 0, 0, 0, 0. Okay, so we have how many zeros? We have 6 zeros. 1, 2, 3, 4, 5, 6. Yes, exactly. So let's try now to convert. Let's see if it is indeed what we were expecting. Yes, it is indeed 1 with 6 zeros, as you guys can see. All right. So this is an interesting property of binary numbers. Sorry, of decimal numbers that are the power of two, because 64 is actually 2 to the power of 6, and 16 is 2 to the power of 4. So, one interesting property is whenever we want to represent decimal numbers in binary, and those numbers are powers of 2, so what we have is simply 1 to the left and a bunch of zeros. So the rest is all zeros. Okay? So if we go back to this, what we drew in the very, in the very beginning of the video, right? So we know that by now that 16 is 2 to the power of 4. Okay? So this here is going to be turned on. This bit here is going to be turned on. Okay, so this is going to be turned on. So remember, it's just energy, right? Energy going through very, very, very small parts of your memory of your computer. And those very, very small parts, we're going to call them bits. So this is turned on. No energy, no energy, no energy, no energy. This is 16 to the power, so this is 2 to the power of 4, or the number 16 in decimal. So 1, 0, 0, 1 with 4 zeros, right? And the rest are zeros. But we don't consider those, okay? Right. We don't consider those in terms of representing 16 as a bunch of ones and zeros. Okay, and 64 we know that is 2 to the power of 6, right? So we're gonna turn this on. This here is gonna be off. 0, 0, 0, 0, 0, 0. Interesting, right? 2. Sorry, if the decimals are powers of 2, if they're powers of 2, so the only thing you gotta do is, hey, you turn on one of these bits here, and the other ones are gonna be turned off. So in other words, 1, and the rest is gonna be a bunch of zeros. Okay? Okay, guys, so that's it for today. Thank you very much for watching this video. If you guys have any doubts, please put a comment down below. Now you guys can exercise, right? Now you guys can, just try to come up with the number, say the number 1000011, and try to represent that in decimal. You guys already know how to do this. If anything wasn't clear, you can put the comments down below. But yeah, a few exercises for you. Try to, for example, represent the number 36 in binary, the number 1,000 in binary, or the number 110111 in decimal. Okay, play around with this. Confirm the answer in that website that I was showing you guys just now, the binary to converter website. If you guys Google decimal to binary converter, your guys are also going to have a few options. And that's it.